Welcome guys. Welcome. Let's get started with physics 10th standard Icse force. So what is a force? Force is an external effort in the form of push or pull which changes or tends to change the state of rest or of uniform motion of a body along a straight line, or the direction of motion of the body, or changes tends to change the shape of the body. So this is a definition of a force. Now there are kinds of forces like contact force and non-contact force. So in contact force, few examples which is mentioned in your textbook are frictional force, normal reaction force, tension force as applied by the string, force exerted by the spring, force exerted during collision. They're all contact forces. Non-contact force, gravitational force, electrostatic force, magnetic force. So now we'll try to understand what is a contact force. Contact force is a force which is exerted on an object by another object when it is in direct contact with it. Non-contact force is that force which is acting between two objects when they are not in contact, or in other words, this force is acting when the objects are at a distance from each other. Now, they can ask you a question like what are forces that cause which produces two main effects? Like what are the two main effects, okay, that force causes? So the two main effects are it can change the state of rest or motion of the body, it can produce motion in the body, and it can change the size or shape of the body. That is, it can change the dimension of the body. Okay. When can these two things take place? Based on the types of object. So what are the types of objects? That is rigid and non-rigid. A force when applied on a rigid object does not change the interspacing between its constituent particles, and therefore it does not change the dimension of the object, but causes only the motion in it. On the other hand, a force when applied on a non-rigid object changes the interspacing between its constituent particles and therefore causes a change in its dimension and also produces motion in it. So now we'll try to understand some examples. The push exerted by a broom moves the trash. A ball lying on the ground moves when it is kicked. The pull exerted by a horse makes a cart move. The pull exerted by a steam engine moves a train. The force due to gravity makes an apple fall. A fielder on the ground stops a moving ball by applying force with his hands. When force is applied on the pedal by a cyclist, the speed of the cycle increases. A free falling object continuously gains speed due to the earth's pull, acting along its direction of motion. The speed of moving vehicle is slowed down by applying the brakes. A stone tied to one end of a string, whirling at a constant speed in a horizontal circle, changes its direction of motion continuously due to the force of tension in the string. In cricket, tennis, and badminton, the direction of motion and the speed of the ball is changed by hitting it in the direction other than its direction of motion. A player applies force with a hockey stick to change the speed and direction of the motion of the ball. So there are all some examples. Now we'll try to understand what is frictional force. When a body slides or rolls over a rough surface, a force starts acting on the body in the direction opposite to the motion of the body along the surface in contact. This is called a frictional force or the force of friction. The next one is, say, this frictional force can be felt everywhere. See, for example, when we are walking, so the force exerted by you makes you move, whereas at the same time the frictional force offered by the road helps you to move. So the frictional force is offered by the road in the opposite direction you're walking. We'll try to understand normal reaction force. When a body is placed on a surface, the body exerts a force downwards equal to its weight on the surface, but the body does not move or fall because the surface exerts an equal and opposite force on the body normal to the surface, which is called normal reaction force. Let's see tension force. So when a body is suspended by string, the body due to its weight pulls the string vertically downwards, and the string in its stretched condition pulls the body upwards by a force which balances the weight of the body. This force developed in the string is called tension force. Now we'll try to understand force exerted by the spring. Consider two objects A and B attached to two ends of the horizontal placed spring. In its original loose form, the spring does not exert any force on the object. If the spring is compressed, then what happens? Then the spring pushes the objects away. Okay, if the spring is stretched, what happens? The string brings back the objects to closer point. That is, if the spring is compressed, it pushes away the object with a force attached to its ends, while if the spring is stretched, it pulls in each object with a force attached to its end. In each case, spring has a tendency to come back to its original form, and this force is called this force exerted by the spring, and it is sometimes called restoring force also. Next is force exerted during collision. When two objects collide, they push each other. As a result, equal and opposite forces act on each body. A body B, while in motion, collides with a body A and exerts a force FAB on an object A, which is called the force of action. At the same instant, the body A also exerts an equal and opposite reaction force FBA on the body B. As a result of these forces, the two objects move apart after the collision. Let's see now non-contact force like gravitational force. So gravitational force is the force of attraction which is offered by the earth. The earth also, because of its mass, attracts all other masses around it. The force on a body due to earth's attraction is called the pull of gravity or the force of gravity. It causes motion in body towards earth if the body is free to move. Thus, it is the force due to gravity that makes a body fall when released from a height. The body also attracts the earth by an equal force, but no motion is caused in earth because of its huge mass or inertia. This can be a give reason question. Both objects attract, but when a falling body does not move the earth is because of its huge mass or inertia. Electrostatic force. Two like charges repel while two unlike charges attract each other. The force between the charges is called electrostatic force. This force acts between charged objects even when they are separated. Example is when a comb is rubbed on a dry air, it gets charged. If this comb is brought near the small bits of paper, opposite charges are induced on the bits of paper and they begin to move towards the comb. This is the example of electrostatic force. Next is the magnetic force. Two like magnetic poles repel, while two unlike magnetic poles attract each other. The force between two magnetic poles is called magnetic force, and this force acts when the magnetic poles are at a separation.